on Friday, we just started talking about ellipses, right? And circles. So circles are obviously perfectly round. The distance from the center to all the edges are the same distance. That's your radius all the way around would be the same. And then we got ellipses, which are more like the ovals, where they have a center, but there's two different distances. They could either be stretched horizontally or stretched vertically, so they're not perfectly round. This is a vertical plane, something that's going vertically through the two cones, and it causes two, they look like little buckets, but they're two parabolas, one pointing up, one pointing down, or they can be horizontal, and they can be going from left to right. Let's say that those cones were turned horizontal. That's when that would happen. We talked about how to solve this for y so that you could plug it into your graphing calculator and get the actual shape. So we subtracted the x minus 1 squared, and then we square rooted both sides, and then added the 1 to get the y by itself. And then this one, we subtracted the 45x squared, we divided by 25, and then square rooted. And the biggest thing to remember when you're square rooting is what? You got to do plus and minus, right? And then you should have two curves that connect to form this circle or this ellipse. So this is where we left off, right? Example 3. It says graph the equation on a graphing calculator, identify each conic section, and then describe the center and the intercepts. So work to solve this equation for y. This one's not too complicated. And then either use your handheld graphing calculator or the app to graph it. And then once you get the graph, identify the center and the intercepts. So I'll let you work on that a little bit. Remember, your first goal is to get the y on the side by itself. All right, so I'm going to subtract the x squared and get y squared equals 49 minus x squared, and then square root both sides, making sure I put a plus and minus in front of that 49, or in front of the root. So I have two equations here. Y equals a positive square root 49 minus x squared, and y equals a negative square root of 49 minus x squared. This is a good question because it came up a couple times. All right, so if I look at this expression underneath here, square root of 49 minus x squared, this is not the same thing as this. So when it's multiplication, I can actually break that apart and say that that's the square root of 49 and the square root of x squared, which becomes 7x, right? But this is a package. These two go together. You can't break them apart. The only thing you could do is if that was a perfect square when I factored it, but it's not. It's 7 plus x and 7 minus x. So it's not duplicated. It's not a perfect square. Okay. If you ended up like 49 minus 14x plus x squared, that would break down to be 7 minus x and 7 minus x. That's the perfect square, right? But that's not happening here. These are not the same, so it can't be reduced. Ian?
So it works in multiplication and division because they're technically.
It's one term.
Because like those divisions would be like kind of like the same fraction.
Exactly. So multiplication, division, you can break it apart, but as soon as you see a plus or minus in between those two terms, that is now something that cannot be broken apart. Does that make sense? Okay, good. All right, and then we graphed it. So let's pull up the graph. Come on. And this is what the graph looked like. So because the distance from the center would have been 0, 0. The distance from the center to each of the 4 points is 7. And it's the same in every direction. I know this is what type of conic? It's a circle. The center is at 0, 0. And what else did I ask? The intercepts. The x-intercepts are at 7, 0, negative 7, 0, and the y-intercepts are at 0, 7, and 0, negative 7. So for tomorrow's homework check, you'll get like kind of two separate problems. One is solve this equation how you would type it into your graphing calculator, and it will be done on paper, okay? So that's the first step. If you can get that step, that's kind of like one question. And then the second part is I'm going to give you the graph of a conic. You're going to tell me what kind of conic it is, and then based on that, give me the intercepts, the center, whatever it's asking for. Okay, so 1, you got to make sure you know how to solve an equation for y. 2, you got to make sure that you can identify the type of conic, and then give whatever it's asking for. So if you can read the graph, you should be able to find the intercepts and the center, that kind of stuff. All right, last one like this, and then I think we move forward, right? Because this should be the last ellipse or hyperbola, or circle. 4. Okay, so when you solved, hopefully everybody got plus and minus the square root of 225 minus 9x, that should be squared, divided by 25. Raise your hand if you got at least to that point. Okay, good. Then when you plug it into the graphing calculator, you should have gotten a shape something like that. Okay, and depending on how you're zoomed, remember it might look different, but pay attention to what's happening to your intercepts. So are the intercepts or the distance from the center to the top, the vertical parts, the same as they are to the horizontal? No, which means that this is a what? An ellipse, okay? So this is an ellipse. And if you went 1, 2, 3, that's 1, 2, 3, 3. Those are your y-intercepts, which are 0, 3, 0, negative 3. And your x-intercepts are at 5 and negative 5. That's how I know that this is not a circle. So 5, 0, negative 5, 0. And then my center is right there at 0, 0. Okay, so next conic is a parabola. So remember, if I had that cone, that solid cone, and I took a plane of some sort and I sliced it kind of diagonally running from top to bottom, this little shape is formed, and this is your parabola. So parabolas are probably the things that you've been most exposed to this year. Okay, it's a single curve where the hyperbola has 2 branches, meaning 2 like parabolas that bounce off of each other. The equation of a parabola contains either an x term or a y, or an x squared term, sorry, or a y squared term, not both. And the equations of the other conics usually contain both x squared and y squared. So the parabola is the only one that has just a single term squared, either the x or the y. Everything else has both. The circles have both x squareds and y squareds. The ellipses have both x squareds and y squareds. And you'll see in a little bit, the hyperbolas have both x squared and y squared. The parabola is the only one that just has one. Ian, you had a question?
Is there still going to be like a y equals thing though?
Yeah, so you'll see. They'll still be in standard form. You'll still be solving for y. Okay, and then the last one is hyperbola. So a hyperbola actually is why there's usually 2 cones drawn. Because within a hyperbola, you get one going this way and you get one going this way. So I'm going to go back to. So because they contain 2 curves that open in opposite directions, they are going to be classified as opening horizontally, vertically, or neither. So horizontal would be if they, or not, that's vertical. Horizontal would be this way and this way. This would be a horizontal hyperbola. And then vertical would be up and down. And then obviously, if neither of those, then it would be neither. All right, so this says, graph each equation on a graphing calculator and identify the conic section. Describe the vertices in the direction that the graph opens. So what should you notice about this one that makes life a little bit easier? It's not y squared. It's already solved for y. You don't even have to solve anything. All you got to do is type that in your calculator. So negative 1/2 x squared. All right, so I put this into my graphing calculator as it is, and I got what kind of a shape? Parabola. Why should you have been able to tell me before you even graphed it that it was a parabola? There's only one squared, right? The y is raised to the first power. Parabolas are the only ones that are like that. Either the y or the x is going to be squared, not both. So then it says, describe the vertices. So remember, the vertex is where it changes direction, where it changes from going up to down or down to up, which in this case is right here at 0, 0. And then the direction of the graph, does this open upward or downward? Good. So depending on what kind of conic it is, it's going to ask you for different information because a parabola doesn't have a center, right? Okay, so before you even solve for this or graph it, could you tell me what you think it's going to be, a parabola or a hyperbola? Hyperbola, okay, why? They're both squared, okay? So I'm going to solve for y. I'm going to move the x squared to be on the side with the 9, and then square root, making sure I do plus and minus 9 plus x squared. And then in my graphing calculator, I'm going to type in square root of 9 plus x squared and negative square root of 9 plus x squared. So, normally we say simplify as much as possible. In the case of this situation, I wouldn't. I would make sure that it stays underneath, make it easier on yourself. Okay, so I'm going to pull in the picture. This is what we just got, which is a hyperbola. Okay, this time there's 2 vertices on a hyperbola, right? Because there's 2 parabolas. So one is here, which is at 0, 3. One is here at 0, negative 3. And then which way do these open? Vertically or horizontally? Vertically. All right, so when you solve, divide by 2, and then square root, plus and minus the square root of x plus 2, okay? And if you think about what you're doing, you're basically taking 2 square root functions, one's that's positive and one's that's negative, and that's why they meet that way, okay? If it was just the square root of x over 2, that's 1/2 x, that's this one, just by itself. And then we said, okay, but also do the negative one. The negative one would flip it upside down, which is what this is. So what happens? What do those 2 form? Which shape is that? Parabola or hyperbola? Parabola. Vertex is at 0, 0. And which way does this open? To the right, right? So with a parabola, you want to be specific. Up, down, right, left. Okay? With a hyperbola, it's going to be vertical or horizontal. Or up or down and left and right, which is fine by me for now. Okay, I'm going to come back to this. So let's get to midpoint and distance just to make sure we do it before the end. So 2 formulas that you're going to use sporadically throughout this chapter are midpoint and distance. Okay? These hopefully have been since Algebra 1 we've been doing midpoint and distance. But to find the midpoint, you're finding the point directly in the middle of 2 given points. So you're finding the average of the x's, the average of the y's. If I gave you 2 coordinate points, 2 x, y values, you would add the 2 x's, divide by 2, add the 2 y's, divide by 2 to get the midpoint. And then the distance formula is used to find the distance between 2 points, and that's the square root of x minus x1 squared plus y minus y1 squared. Again, you would be given 2 points. So let's say I had a point here and a point here, and the first thing I want to do is find the distance in between, or the midpoint. Then I would use the first equation, that's the midpoint, and if I wanted to know the distance between them, or the length of that segment, that would be the second equation, which is distance. So this one says, find the center and the radius of a circle that has a diameter with endpoints of 5, 4, and 0, negative 8. So first try to picture what it's talking about. So if I have 5, 1, 2, 3, 4, 5, 4, I've got a point here, 0, negative 8, 1, 2, 3, 4, 5, 6, 7, 8 here. This is the diameter. What's the diameter of a circle? That's the circumference. What's the diameter? It's the whole distance all the way across, right? So if I have a circle, that would be what the diameter would look like, right? It's going to run, and it has to run through the center of the circle, okay? It's a chord, technically, because it's got endpoints on the circle, but it has to run through the center of it, okay? The radius is half the diameter, right? We know that? Okay, good. So if I wanted to find the center of that, In relationship to those 2 points, what is that point? What's the center? It's the midpoint between those 2 endpoints. You see that? Yes? So the midpoint of this segment is my center. So I'm going to find the midpoint of those 2 points. So I'm going to do 5 plus 0 divided by 2, and then 4 plus negative 8 divided by 2, which is 5 over 2, and negative 4 over 2, which is 2.5, and negative 2. And if I graph that, like equally space my spaces out on an actual grid, that point should be exactly there, 2.5 and negative 2. Mine's a little bit off because I did it by hand, but you kind of get the idea. And then it says find the radius. So if I wanted to know the length of this segment, how could I find it? Okay, I could do the distance of the whole endpoint, of the whole diameter, divide by 2. That's one way. What's another way? What's that point we just found? I could find the point in the middle to the edge, right? That's one way. If I found the distance between those 2 points, is it my radius? Yeah. If I found, change the color. If I found the distance between these 2 points, does it represent my radius? Yes. So one option is find the whole diameter's length and then divide it by 2. The other is find the distance between the center and the side. So honestly, because there's a fraction in the midpoint, I would probably go with the first one this time. I would find the distance between these 2 points. So I'd get the square root of 0 minus 5 squared plus negative 8 minus 4 squared. I get the square root of negative 5 squared plus negative 12 squared, 25 plus 144. Thank you. Which is the square root of 169. Do you know what the square root of 169 is? God bless you. 13. And then that's my diameter. So I have to do what to that to get the radius? Divide it by 2. So you're going to use the distance and the midpoint sporadically throughout the next couple of sections. All right, so we found the center is the midpoint between the 2 endpoints. Should have been 814. Raise your hand if you got that one right. Okay, good. And then this time, instead of, because they were whole numbers, it's sometimes just as easy to do the center to the edge, which is what I did this time. So center would have been 814. And then you can pick either endpoint, because if you've done it correctly, then the distance from the center to either endpoint is going to be the same. So I picked smaller numbers just because they were smaller numbers. Okay, and I ended up getting the square root of 100, which is 10. Had you done the entire diameter, you should have gotten 20, and then cut it in half, and you should have gotten 10. Questions overall on any of it? Okay, so again, tomorrow's homework check. Make sure you know how to solve an equation for y. Make sure that you can identify the type of graph, and make sure that you can tell me information about that graph, whether it be vertex, center, intercepts, which direction it faces, and then classify it. Circle, hyperbola, ellipse, parabola. Okay? Questions? All right, so I posted a practice. I'm actually hitting publish as we speak. You do not need to submit because your homework check's gonna be in class, okay? But my advice is to make sure that you complete it. So don't worry about that last, just do 1 through 13. I should add it right on there. And I'll post the answers to it. Mm-hmm. 45. Have a great day.
I can make up the quiz from last week after school today, right?
Correct. 402.
All right, thank you.
So it's you and, shoot, who else does me the quiz? The quiz from last week. Thought it was, I wrote their names down. Oh, it's Jen. That's who it is. How were they? They're graded. They average like an 82, 83. It's been there since Friday. Oh, did you say wasn't mine put in? Have a good day. Thank you.